Okay, so welcome back, and now what we're going to do is we're going to talk about differentiating to find series for a given function. So we're going to use what we've been using in the previous videos to come up with representations of functions that are derivatives of other functions. So this is where we're going to use term by term differentiation like we did before. So in this example it says use the binomial series for this function, which we're familiar with, to find the binomial series for this function. Now what we're going to notice here is this is a derivative of this, or it's similar to it, right? Because how do I write this? 1 over, or no, let me do this. So we know that the derivative with respect to x of the square root of 1 plus x is equal to 1 over 2 times the square root of 1 plus x. Okay, so that's what we have. Okay? So, the binomial series for this then is going to equal what? Well, just we're going to multiply both sides by 2, right? So we get 2 times that, which then means, well, what do we get? Well, we already know that the series is going to be the same. So if we look at this, then we're going to take the derivative of this. But this is equal to the binomial series, right? So we know what the series is, and the fact that we can, if it's convergent, right, which it is, it's convergent over that interval from -1 to 1, right? And so since we can, it's convergent, then we can go ahead and take the derivative of this term by term. And when we do that, what we're going to end up with is this is going to equal 1 plus, and then it's going to be the summation from n equals 1 to infinity of -1 to the nth power. So instead of n plus 1, it's going to be n, because again, we're taking the derivative. And this is going to be over n factorial, and it's going to be x to the nth and 2 to the nth, right? But we're still going to have, let me expand this out. So remember, it's going to be 3 times 5 2. It's going to be now instead of 2n plus 3, or excuse me, 2n minus 3, it's going to be 2n minus 1. Okay, and then there's going to be, on the bottom here, it's going to be 2 to the nth power, right? And then this is going to be times x to the nth power. And that's going to be the new series. And so again, the way you get to this point is, again, we're just taking the series and we're taking the derivative with respect to x, okay? And so when we do that, we're going to end up getting, instead of x to the n plus 1, it's now going to be x to the n, and then these are going to be reduced to n as well, okay? And that's it. Have a great day.